Now the hardware is ready, the setup is ready. We can start the software by clicking on the software, ShopPro. Here you can either create a new project or open an existing project using the browser. Let's say the project name is Project 1. And we are in the menu. The first step is to select the work material. These arrows will guide you through the software. First, let's select aluminum alloy, and we are selecting aluminum 7050 T6 material. If it is necessary, you can add new material to our database. That becomes user-specific material. We have approximately 250 materials in the database. You can select up milling, down milling, slotting, or user-specific cutting condition. Let's select slot milling operation. We have 4 teeth on the cutter. Diameter of the tool is 3/4 inch or 19.05 millimeter. By the way, the software can be activated either in metric or in imperial units. And the feet per tooth is selected as 0.1 millimeter as an example. It is important to note that always in the software, the feed direction is called X, normal to the feed is Y. These have nothing to do with machine tool axis directions. So when the machine is measured, the feed direction must be aligned with the x-axis during hammer testing. Then we click Next. Now we have to set up the hammer calibration parameters. You can add and edit the hammers you have in the factory only once, and the software remembers them. We have, for example, now Kistler 9722 A2000 hammer with a calibration factor of 2.13 millivolt per Newton. This calibration or sensitivity factor comes with the hammer sent by the supplier. The first channel contains the accelerometer, as we explained earlier. You can either connect accelerometer or displacement sensor, but accelerometer is more commonly used in the shop because it is easier to set it up. We have PCB accelerometer with 5.325 millivolt per G sensitivity factor. The next is the number of impact tests you have to collect in order to complete the measurement. We recommend that you hit at least 5 times. Then the software automatically averages the measurements out of 5 measurements. If you have cutters with small diameter, then it is recommended that you increase the number of measurements about up to 10, 15. Next is the frequency range. If you have a cutter like this, which has 19 millimeter diameter, typically the frequencies will be beyond 400 Hertz up to 5000 Hertz. Because accelerometer does not measure low frequency vibrations very well. But you can always change this range during the processing of the results. Here we have user note area. This is not essential to complete. It is just reminder notes for you for later use. The next is FRF setup. FRF means hammer test, basically. Some machines have identical dynamics in X and Y directions of the machine if the spindle is perfectly symmetric. In some machines, however, this is not symmetric because of the mounting of spindle on the machine tool column. You can easily see this by looking at the measurements. Let's assume that we don't have a symmetric machine and we leave this one unchecked. Next is read existing FRF measurement. If you are making the measurement, you don't need to click on this. If you have already collected measurements before, then you can simply bring those hammer test results to the software using browser. Let's assume we don't have previous measurement. We click next button. Now we are in the tab testing window. You can always go back and change the measurement settings. We have to collect measurements in two directions because spindle is not symmetric. The first one is the feed direction, the second one is the normal direction. Software automatically tells you to start with the feed direction. As soon as I click start button, I have to start hitting with the hammer. If anything goes wrong in between, you can reset the software and start from the beginning of the measurement again. Now I will click start and start the measurement.